everyone, welcome to happymath.com. So this time we continue to cover two small independent sample hyper testing. Okay, so this time we are using the actual data and then analyze it. So please look at this question. The tensile strength of a metal is a measure of its ability to resist tearing when it is pulled lengthwise. A new experimental type of a treatment produces steel bar with the following tensile strength. Okay, experimental method and old method, they are the basically resisting tearing value here, and the alpha equal to 0.01. Does the new treatment make a difference in the tensile strength of a steel bar? Assume the population variance are equal and the samples are random. Okay, so now we want to say just where the H, A, and the hypothesis claim located here. So now when I look at here, it shows that difference basically, right? Which means claim is on HA. So I'm gonna make mu. So I'm going to do mu1. So it's not equal to mu2. So the difference basically, and that's our claim. And then so H0 means HO, it will be equal to each other basically. Okay. Then now there's no mean value and standard deviation, anything's given. So we need to set up basically data onto these two column here, and then we need to using Excel t value data analysis, and then we can find it. So let's do it. So experimental, and then old method. Okay, so this becomes 363 and 355 and then 350, something like that. You type in like that. I input all this experimental method and the old method here. Okay, then go to data and then click the data analysis. You are choosing here t-test. Now it shows that the population variance are equal, right? So which means you must choose the two sample assuming equal variance, this one equal variance, and then OK. Now the variable one range becomes experimental data here, and then 2 becomes old method here, because I chose title as well, so I'm gonna label, and alpha value was 0.01, so I'm gonna switch to 0.01, and then I want to see the table on the same worksheet, so I will put around right here. Okay, then now, so this is the basically our analysis data here. Okay, so then now, so we already did assuming equal variance, so based on this table we can analyze it. So this time I'm gonna analyze it both p-value test and then t-test here. Okay, so p-value, so this is the two-tail. You see the two-tail here, right? So mu1 equal to mu2, or mu1 is not equal to mu2. So it's a two-tail test basically. So you need to select p-value for two-tail. So this one. So I'm gonna just highlight it. Okay, then I wanna just make this number as decimal so you can see better. Yeah. So that's our two-tail p-value, and then alpha. So alpha equal to 0.01. Okay, so now between p and alpha, so we know that so alpha is greater right? Okay, which means now we can say based on this reject HO. Okay, all right, then also let's confirm the t table, I mean the t test here. So the two tail test, so should be t critical value become 2.83 something. So this one I will just rounding 3 decimal digit. Then because it's two tails, so we can set up negative 2.831 and then 2.831, and now at left side of the negative 2.831 will be 1 over 2 HA located, and then center become HO, and the other, so after 2.831 another half of HA. Okay, so I'm gonna make it all center so we can see better, and I also color so you can see a little bit easily. Then okay, here then now we want to go to sample t-test. So t-statistic is this one, so negative 6.41017 like that. So I'm gonna just rounding around the 3 decimal digit, so negative 6.410. Okay, where this t-value, so t-statistic, where this t-value belongs to, is it half of HA on the left side or center HO, or bigger than, so like bigger than 2.831, so on the right side here. Yeah, exactly. So this one include basically here. Okay, make sense to you? Therefore, since this t statistic belongs to left half of HA, based on that we can also reject HO. Okay, then now we reject HO, and then where was the claim? So the claim was on HA, therefore we can say there is not enough evidence to support evidence to support the claim. Therefore, now we can conclude that so the resisting tearing length is not that different basically. Okay, actually they're same basically. So the tensile strength of a metal, okay, so I can say of metal between two methods are equal. So that's our conclusion basically. Okay, so thanks for joining this time. I will see you with a different video later. Thank you.